everyone. In this video, we're going to talk about the vertex form of quadratic functions and different applications of how we can minimize and maximize these quadratic functions. So the first thing is we are used to seeing our quadratic functions in the form on the left. So here we have f of x equals ax squared plus bx plus c. But when we want to see some other properties of our graph of our quadratic function, it's nicer if we have it written in vertex form, which is here on the right-hand side. So we have f of x equals a times the quantity x minus h squared plus k. And so how do we move from the standard form on the left-hand side to the vertex form on the right-hand side? Well, we need to do something called completing the square. And so to demonstrate what completing the square means, I have a diagram here for us. And in this diagram, we're only considering the expression x squared plus bx, so the first two terms of our standard form quadratic function. And so I can represent x squared by the x by x box or square. And then for the term bx, I can represent that with a rectangle that has a width of b and a length of x. And so if I'm trying to construct a square with these two terms, then one thing I could do is I could split this bx rectangle in half down the middle, and I can put that on both sides of my x squared square. But when I do, I am missing a tiny square, which has the area of b over 2 squared. And so that's what we're going to do when we complete the square. We're going to add that b over 2 squared in. But remember, we can't just add extra things to an equation. We're going to have to add it trickily. And I'll show you that trick when I am going to complete the square algebraically with our standard form quadratic function. Now, just a little note here, when we're completing the square for the purposes of this class, you're going to have values for a, b, and c, whereas here I'm completing the square for just the general quadratic equation of ax squared plus bx plus c. So I will show you an example later on in the video with numbers instead of all variables. And so if you'd like to, you can skip through this part of the video if you're not interested in seeing this done in the general case. All right, but now we are going to do it in the general case. So first thing is we start off with our standard form of f of x equals ax squared plus bx plus c. And the very first thing that I'm going to do, because I'm trying to complete the square and get this to look like our f of x equals a times quantity x minus h squared plus k. So I'm going to factor out an a in my first two terms. So what I mean by that is we're leaving c all by itself, but I need to figure out, okay, if I take out an a from this ax squared, we're left with x squared. And if I'm trying to take out an a from this bx term, well, I can think of this as a times what gets me bx, and that's going to be a positive b over ax. If you don't believe me, we can always distribute this a back to these two terms in parentheses, and we should get ax squared plus bx back, and we do. The next part is we're going to add this missing square. And so that missing square, in this case, because we have over a, so this would be b over 2a, we're adding a b over 2a squared in our parentheses. Now, like I said, we can't just add something and make a completely different equation. We need to add it in a very tricky way. And what I mean by that is we're going to add 0. So right now we've added b over 2a squared, so we need to subtract that. And I'm going to subtract that on the outside of my parentheses. But in order to do that, I need to recognize that this b over 2a squared is actually being multiplied times an a. So I need to subtract that a times b over 2a squared. So here we added 0. So now what I have in my parentheses, I can actually write as a perfect square. So in this case, we're going to have x plus b over 2a, and that quantity is squared. And then we still have what we have on the outside, so plus c minus a times b over 2a squared. Now, I'm almost there, but I'm going to need to do a little bit of substitution to get it to looking exactly like our vertex form that I showed you above. And so to do that, we're going to let h equal negative b over 2a, and we're going to let k equal c minus a times b over 2a squared. So therefore, we can rewrite this equation above as f of x equals a times x minus h squared plus k. So now we have our vertex form, and we had to complete the square to get there. So one thing to note here is that our vertex is at the point hk. So if we were asked to just find the vertex, we could use these formulas here. We can use given our standard quadratic equation, we can find the vertex or the x value of our vertex by calculating negative b over 2a, and then our y value of our vertex by calculating this formula we have for k, which you'll see an example of in just a second. So completing the square, why is it that we're wanting to put a quadratic formula or function into vertex form? And the reason is because the vertex is super important for different properties of our graph. So one of the properties is that it tells us if or where our maximum or minimum value is. So in our vertex form, let me rewrite that. In our vertex form, if RA is bigger than 0, so if it's positive, that tells me we have an upward facing parabola, just like I have here in this diagram. And so then that tells me that my vertex is going to be a minimum. And like I said, it's at the vertex, HK. If A is less than 0, then that means that it's going to be negative. So we are going to have a downward facing parabola, and that our vertex is going to be a maximum value at that HK. All right. So now let's go ahead and do some examples. So first off, we are going to complete the square to rewrite this quadratic function in vertex form. So remember, the very first step is we need to factor out the leading coefficient from these first two terms. So in this case, our a, or our leading coefficient, is negative 1. So I'm going to factor that out. So we're going to have x squared and a negative 10x in parentheses. Again, if we want to, we can multiply this back out and see, do we get the same thing in our original equation? And we do. Negative times x squared is negative x squared. Negative 1 times negative 10x is a positive 10x. All right, so now the second step was we were going to add in that little missing square. And remember, that square is b over 2a squared. And so let me identify our b from our equation. Well, that's the coefficient of our x, so it is 10. And we can calculate this as 10 over 2a, and our a was negative 1, squared. Well, 10 divided by a negative 2 is going to be -5, and that is squared, so we get positive 25. So our second step is in our parentheses, we are adding 25. But outside of our parentheses, remember, we can't just add something, we have to also subtract. And so on the outside with our -21, we're going to first multiply this positive 25 times -1, and then we're going to subtract that. So we're going to subtract a -25. Our next step is we can rewrite what is in parentheses here as a perfect square. So it is x minus 5 squared. And the reason it's -5 here is because -5 times -5 is positive 25, and a -5 plus a -5 is a -10. And again, you can always do the distribution to double check and make sure we get the same thing in our previous step. And then we have a -21 minus -25, so that's plus 25. And so now we'll have our final vertex form is negative times the quantity x minus 5 squared, and then -21 plus 25 is positive 4. So there is our vertex form, and we can identify that the vertex is going to be located at the point, remember it's HK, so in this case H is positive 5 and K is positive 4. All right, the next example is an application. So we have the problem that an athlete shoots a free throw in a basketball game, and the athlete shoots the ball from a height of 6 feet. The height of the ball, f of x, in feet can be modeled by the equation f of x equals -1/10 times x squared plus 1/6 x plus 6, where x is the ball's horizontal distance in feet from where it was thrown. And our question is, what is the maximum height of the ball and how far from the free throw line does this occur? So if we're looking for a maximum height and our equation is modeling the ball height, then that means that we're looking for the vertex. And again, you can notice here that our A is a -0.1. So our A is less than 0. So that means we're going to have a downward facing parabola, and we're going to have a max at our vertex of HK. Now, in this case, we're looking for the maximum. We can actually find the vertex without having to complete the square. And like I had shown you above, when we completed the square in our general equation, is we can calculate the x value of our vertex, or our h, as -b over 2a. So let's go ahead and write that down. And let's go ahead and identify those parts from our problem or our equation. So we already found what a is. B is going to be our coefficient of our x term, and that is 1.6. So calculating h, we get -1.6 divided by 2 times -0.1. And when we plug that into our scientific calculator, we get a positive 8. And then we can now find our k, or our y value of our vertex, by plugging this value 8 in for x in our original equation. So f of 8 is going to be equal to, so now I'm replacing x with 8 in my original. So we get -0.1 times 8 squared plus 1.6 times 8 plus 6. And I can plug all of this into my scientific calculator, and I will get the value of 12.4. So my vertex, or my maximum, is at the coordinate 8, 12.4. Now, if you think about a coordinate plane, let me draw one. remember that x is our horizontal axis and y is our vertical. So x is going to be our horizontal distance. So in this problem, I'm asked what is the maximum height of the ball? Well, height is vertical, so that can't be my x value. But how far from the free throw line does this occur? Well, the ball is traveling vertically toward the basket. So if we said that this free throw line was at the origin and our vertex here is at 812.4. So let me just model this. So if this was the trajectory of our ball, then the max height of the ball, that is going to be our y value. That's our vertical distance. So the max height of the ball is going to be the 12.4, and this is all measured in feet, we're told. And then the distance from where we had started, or where our free throw line was, that is going to be the x value. So our horizontal distance that the ball traveled was 8 feet. So this max occurred 8 feet from the free throw line. And there is our final answer. So you could have found the vertex by completing the square with our standard form quadratic equation, or you can just use our formula for calculating h, plug the value you get back into your original equation for x, and you'll find your k value. I hope you find this video helpful and wish you luck as you are completing the square and finding those vertex points.